Cobol.
Cobol is a compiled computer programming language designed for business. It is imperative, procedural and, since 2002, object-oriented. It was designed in 1959 by the Conference on Data Systems Languages and was largely based on previous programming language design work by Grace Hopper. Cobol stands for Common Business-Oriented Language. Cobol is primarily used in business, finance, and administrative systems for companies and governments. In 1997, Gartner Group estimated that there were a total of 200 billion lines of Cobol in existence, which ran 80% of all business programs. Cobol was one of the first programming languages to be standardized. The first Cobol standard was issued by ANSI in 1968. The standard has been revised 3 times since then, with ISO publishing the latest standard as ISO IEC 1989-2002.
History and specification. Cobol 60.
A meeting chaired by Charles A. Phillips, director of the Data System Research Staff, was held at the Pentagon on May 28 and 29 of 1959, exactly 1 year after the Zurich ALGOL 58 meeting, to discuss creating a common programming language for business. The Department of Defense was concerned about whether it could run the same data processing programs on different computers, a task which the only mainstream language, Fortran, could not handle. There, it was agreed to start a project to create a common, business-oriented language. The language's objectives were to allow efficient, portable programs to be easily written, to allow users to move to new systems with minimal effort and cost, and to be suitable for inexperienced programmers. It was decided to set up 3 committees, short, intermediate and long range. However, in the end, the short-term committee designed the language because the intermediate range committee formed, but never became operational, and the long-range committee never formed. The committees eventually merged to form CODASYL. I1.1. It was the short-range committee, chaired by Joseph Wegstein of the U.S. National Bureau of Standards, that created a description of the first version of Cobol in the following months. The committee was formed to develop a language which would take the best parts of Flowmatic, IMACO, and Comtran while being superior to them all. I1.2 The committee worked under the assumption that they would be creating a stopgap which would be replaced ID/9. The specifications were greatly inspired by the Flowmatic language invented by Grace Hopper, 10 to 11 commonly referred to as the mother of the Cobol language. Flowmatic's status as the only language of the bunch to have been implemented made it particularly attractive to the committee. The IBM Comtran language invented by Bob Beamer was also drawn upon, but some of its features were not incorporated into Cobol so that it would not look like IBM had dominated the design process. ID/9 The fact language specification from Honeywell was not distributed to committee members until late in the process and had little impact. The committee was made up of members representing 6 computer manufacturers and 3 government agencies. The 6 computer manufacturers were Burroughs Corporation, IBM, Minneapolis Honeywell, Honeywell Labs, RCA, Sperry Rand, and Sylvania Electric Products. The 3 government agencies were the U.S. Air Force, the Navy's David Taylor Model Basin, and the National Bureau of Standards, now National Institute of Standards and Technology. I2.1.1 It soon became apparent that the commit was too large for any progress to be made quickly. A subcommit was formed and was made up of 6 individuals. William Selden and Gertrude Tierney of IBM, Howard Bromberg and Howard Discount of RCA, Vernon Reeves and Jeannie Sammet of Sylvania Electric Products. The decision to use the name Cobol was made at a meeting of the committee held on September 18, 1959. The subcommittee completed the specifications for Cobol in December 1959. I2.1 The specifications approved by the full short-range committee were approved by the Executive Committee on January 3, 1960, and sent to the Government Printing Office, which printed these as Cobol 60. The CODASYL Executive Committee later created the Cobol Maintenance Committee to answer questions from users and vendors and to improve and expand the specifications. 47. The first compilers for Cobol were implemented later that year, and on December 6 and 7, the same Cobol program ran on an RCA computer and a Remington Rand Univ computer, demonstrating that compatibility could be achieved.
Cobol 61 to Cobol 65.
Cobol 60 was replaced in 1961 by Cobol 61. This was then replaced by the Cobol 61 extended specifications in 1963, which introduced the sort and report writer facilities. 48. Cobol edition 1965 brought further clarifications to the specifications and introduced facilities for handling mass storage files and tables. I 2.2.4.
ANS Cobol 1968.
Efforts began to standardize Cobol to overcome incompatibilities between versions. In late 1962, both ISO and the United States of America Standards Institute, now ANSI, formed groups to create standards. ANSI produced USA Standard Cobol X 3.23 in August 1968, which became the cornerstone for further versions. I 2.3. This version was known as American National Standard, ANS, Cobol.
Cobol 1974.
In 1974, ANSI published a revised version of ANS, Cobol, containing new features such as file organizations, the delete statement and the segmentation module. Deleted features included the note statement, the examine statement, which was replaced by inspect, and the implementer-defined random access module, which was superseded by the new sequential and relative I/O modules. These made up 44 changes which rendered existing statements incompatible with a new standard. The report writer was slated to be removed from Cobol, but was reinstated before the standard was published.
Cobol 1985.
In June 1978, work began on revising Cobol 74. The proposed standard, commonly called Cobol 80, differed significantly from the previous one, causing concerns about incompatibility and conversion costs. In January 1981, Joseph T. Brophy, Senior Vice President of Travelers Insurance, threatened to sue the Standard Committee because it was not upwards compatible with Cobol 74. Mr. Brophy described previous conversions of their 40 million line code base as non-productive, and a complete waste of our programmer resources. Later that year, the Data Processing Management Association, DPMA, said it was strongly opposed to the new standard, citing prohibitive conversion costs and enhancements that were forced on the user. During the first public review period, the committee received 2,200 responses, of which 1,700 were negative form letters. Other responses were detailed analyses of the effect Cobol 80 would have on their systems. Conversion costs were predicted to be at least 50 cents per line of code. Fewer than a dozen of the responses were in favor of the proposed standard. In 1983, the DPMA withdrew its opposition to the standard, citing the responsiveness of the committee to public concerns, and a National Bureau of Standards study concluded that the proposed standard would present few problems. 41. A year later, a Cobol 80 compiler was released to DEC-VAX users, who noted that conversion from Cobol 74 programs posed few problems. The new evaluate statement and inline perform were particularly well received and improved productivity, thanks to simplified control flow and debugging. The second public review drew another 1,000, mainly negative, responses, while the last drew just 25, by which time many concerns had been addressed. In late 1985, ANSI published the revised standard. 60 features were changed or deprecated and many were added, such as 150 scope terminators, ENDIF, ENDPerform, ENDREAD, etc., nested subprograms, the continue statement, the evaluate statement, the initialize statement, inline perform body, reference modification, I/O status codes. Two amendments followed in 1989 and 1993, the first introducing intrinsic functions and the other providing corrections. The 1985 standard and its amendments were adopted by ISO, who subsequently took primary ownership and development of the standard.
Cobol 2002 and object-oriented Cobol.
In the early 1990s it was decided to add object orientation in the next full revision of Cobol. Object-orientated features were taken from C++ and Smalltalk. The initial estimate was to have this revision completed by 1997, and an ISO committee draft, CD, was available by 1997. Some vendors, including Micro Focus, Fujitsu, Variant, and IBM, introduced object-oriented syntax based on drafts of the full revision. The final approved ISO standard, adopted as an ANSI standard by INSITS, was approved and made available in 2002. Fujitsu Software, Micro Focus and Raincode introduced object-oriented Cobol compilers targeting the .NET framework. Cobol 2002 included many other features beyond object orientation. These included national language support, including but not limited to Unicode support, locale-based processing, user-defined functions, call, and function, prototypes, for compile time parameter checking, pointers and syntax for getting and freeing storage, calling conventions to and from non-Cobol languages such as C, support for execution within framework environments such as .NET and Java, bit and Boolean support, true binary support. Up until this enhancement, binary items were truncated based on the base 10 specification within the data division, floating point support, portable arithmetic results, the validate facility, which had been in the CODASYL Cobol Journal of Development since 1982. 3 core agenda have been published for the standard, 2 in 2006 and 1 in 2009. There are 3 technical reports which describe object finalization, XML processing and collection classes for Cobol.
Cobol 20XX.
The standard to supersede Cobol 2002 is under publication as of 2014. It includes the following changes: Annex E. Portable arithmetic results have been replaced by IEEE 754 data types. Major features have been made optional, such as object orientation, the validate facility, the report writer and the screen handling facility, method overloading, dynamic capacity tables.
Legacy.
Cobol programs are used globally in governments and businesses, and are running on diverse operating systems such as ZOS, VME, Unix and Windows. In 1997, the Gartner Group reported that 80% of the world's business ran on Cobol, with over 200 billion lines of code and 5 billion lines more being written annually. Near the end of the 20th century, the year 2000 problem, Y2K, was the focus of significant Cobol programming effort, sometimes by the same programmers who had designed the systems decades before. The particular level of effort required to fix Cobol code has been attributed to the large amount of business-oriented Cobol, as business applications use dates heavily, and to fixed-length data fields. After the cleanup effort puts into these programs for Y2K, a 2003 survey found that many remained in use. 16 The authors said that the survey data suggest a gradual decline in the importance of Cobol in application development over the 10 years unless integration with other languages and technologies can be adopted. 10. In 2006 and 2012, Computer World surveys found that over 60% of organizations used Cobol, more than C++ and Visual Basic.NET, and that for half of those, Cobol was used for the majority of their internal software. 36% of managers said they plan to migrate from Cobol and 25% said they would like to if it was cheaper. Instead, some businesses have migrated their systems from expensive mainframes to cheaper, more modern systems, while maintaining their Cobol programs.
Features. Syntax.
Cobol has an English-like syntax which is used to describe nearly everything in a program. For example, a condition can be expressed as x is greater than y, although there are more concise forms such as x greater y and x greater than y. More complex conditions can be shortened from a greater than b and a greater than c or a equals d to a greater than b and c or equals d. As a consequence of this English-like syntax, Cobol has over 300 keywords. 8.9 However, compiler extensions mean many implementations have far more. One implementation recognizes over 1,100 keywords. A Cobol program is split into 4 divisions: the identification division, the environment division, the data division and the procedure division. The environment division specifies any program features that depend on the system running it, such as files and character sets. The data division is used to declare variables and parameters. The procedure division contains the program's statements. Each division is subdivided into sections which are made up of paragraphs. Cobol allows identifiers up to 30 characters long. When Cobol was introduced, much shorter name lengths, for example, 6 characters for Fortran, were prevalent. Cobol introduced the concept of copybooks, chunks of code that can be inserted into a larger program. Copybooks are used with a copy statement, which allows code to be selectively replaced, using the replacing clause. For instance, copy foo replacing bar by baz will replace all instances of bar with baz.
Code format.
Fixed format code is the default code format. Up to Cobol 85, fixed format code was split into 5 areas. In Cobol 2002, free format code was introduced. It allowed code to be placed in any column of the file, like newer languages such as C and Pascal. The comment indicator was replaced by greater than, which could be placed anywhere and be used in fixed format source code. However, no equivalent to the slash was introduced and continuation is now only allowed for string literals. Fixed format code remains the default format, however, and the only changes to it in Cobol 2002 were that areas A and B were merged and their size left to the implementer. 1.6
Aggregated data.
Data items in Cobol are declared hierarchically through the use of level numbers which indicate if a data item is part of another. An item with a higher level number is subordinate to an item with a lower one. Data items which are not subordinate to another item are called records. Items that have no subordinate data items are called elementary items. Those that do are called group items. 5.2 In the above example, num and the date are subordinate to the record sum record, while the year, the month and the day are part of the group item the date. Level numbers used to describe standard data items are between 1 and 49. A level number of 66 is used to declare a regrouping of previously defined items, irrespective of how those items are structured. 77 indicates the item is standalone and in such situations, is equivalent to the level number 1. 88 declares conditions names, so-called 88 levels, which are true when the parent data item contains one of the values specified in the condition. 5.2.7
Data types.
Standard Cobol provides the following data types: 118.
Numeric.
Numeric data can be stored in several formats. 13.18.59.3. Binary, where a minimum size is either specified by the picture clause or by a usage clause such as binary long. Usage computational, where data may be stored in whatever format the implementation provides. Often equivalent to usage binary. Usage display, the default format, where data is stored as a string, floating point, in either an implementation-dependent format or according to IEEE 754, usage national, where data is stored as a string using an extended character set, usage packed decimal, where data is stored in the smallest possible decimal format, typically packed binary coded decimal.
Edited.
Edited data are formatted string types that are specified by a picture clause. For example, a 9 indicates that there will be a numeric character at a position and a indicates that there will be a comma character at that position unless the character after it is a space. in which case it will also be a space 5 to 11. There are three types of edited data: alphanumeric edited, national edited and numeric edited. Numeric edited data can be represented using either the normal character set or the national set.
Extensions.
Most vendors provide additional types, equivalents of which are now in the standard. These extensions include 5.2.1.11.
Procedures.
The sections and paragraphs in the procedure division can be used as labels and simple subroutines. Unlike in other divisions, paragraphs do not need to be in sections. Execution goes down through the procedures of a program until it is terminated. Paragraphs are declared with an identifier followed by a period, and sections are declared similarly, with the word section following the identifier. Procedures can be used with a perform statement which acts like a GOSUB in BASIC. Performing a section means that execution travels through any paragraphs it contains, even if doing so will take control flow out of the specified procedures. In Cobol 74, subprograms were added, allowing the separation and encapsulation of different parts of the program. Subprograms can be called either statically or dynamically. Static calls are known at compile time, but dynamic calls are evaluated at runtime based on a string or pointer variable. Intrinsic functions were added to Cobol in the 1989 addendum to Cobol 85. The addendum added various common mathematical, string and date functions including sin, uppercase and current date. Functions may be preceded by the word function, and those with no parameters may be used with or without parentheses. 8.4.2.2 in 2002, user-defined functions were added.
Self-modifying code.
The original Cobol specification supported the infamous alter X to proceed to Y statement, for which many compilers generated self-modifying code. X and Y are paragraph labels, and any GO to X statements executed after such an alter statement mean GO to Y instead. Many compilers still support it, but it was deemed obsolete in the Cobol 1985 standard and should not be used in new programs. The use of alter has been banned altogether for some time by many software companies as part of their programming practices.
Object-oriented programming.
Support for object-oriented programming was added in Cobol 2002. Cobol supports classes and interfaces. Classes have factory objects, containing class methods and variables, and objects, containing instance methods and variables. These objects may implement interfaces, which allows polymorphism. Objects are stored as references which may be optionally restricted to a certain type. Methods can be accessed through the invoke statement or through inline method invocation. Method overloading is not permitted in Cobol 2002. Cobol does not provide a way to hide methods. Class data can be hidden, however, by declaring it without a property clause, which leaves the user with no way to access it. Classes may inherit from the standard class base, which provides the object constructor new and the factory object constructor factory object. A factory object constructor allows factory methods to be called on objects of an unknown type. Support for generic programming is provided through parameterized classes, which can be instantiated to use any class or interface.
Hello, world.
A Hello, World program in Cobol.
Hello, OS/360 circa 1972.
On an IBM System/360 running OS/360 MVT 21.8F, circa 1972, which predates the tradition of using Hello, World for introductory examples, a Hello, World program would have been punched onto 80-column cards, containing source code similar to. The source lines are JCL statements, surrounding the Cobol sequence-numbered source code. The ANS Cobol compile, link, and go module Cobol was typically utilized to compile and execute the code. The resulting Hello, World output would have then been displayed on the operator's console.
Criticism and defense. Lack of structure.
In his letter to an editor in 1975 entitled, "How Do We Tell Truths That Might Hurt?", which was critical of several of Cobol's contemporaries, computer scientist and Turing Award recipient Edsger Dijkstra remarked that the use of Cobol cripples the mind. Its teaching should, therefore, be regarded as a criminal offense. In his dissenting response to Dijkstra's article and the above offensive statement, computer scientist Howard E. Tompkins defended structured Cobol. Cobol programs with convoluted control flow indeed tend to cripple the mind, but this was because there are too many such business application programs written by programmers that have never had the benefit of structured Cobol taught well. Cobol lacked any facility for defining independent subprograms until Cobol 74. This complicated development because it meant that all variables were global and could be modified anywhere within the program. However, its varied control structures reduced the need for GOTOs. The perform statement, for example, allowed programmers to easily access powerful looping facilities 349 to 350. Additionally, the introduction of OO Cobol has added support for object-oriented programming as well as user-defined functions and user-defined data types to Cobol's repertoire.
Compatibility issues after standardization.
Cobol 85 was not fully compatible with earlier versions, resulting in the caesarean birth of Cobol 85. Joseph T. Brophy, the CIO of Travelers Insurance, spearheaded an effort to inform users of Cobol of the heavy reprogramming costs of implementing the new Standard 11. As a result, the ANSI Cobol Committee received more than 2,200 letters from the public, mostly negative, requiring the committee to make changes. On the other hand, conversion to Cobol 85 was thought to increase productivity in future years, thus justifying the conversion costs.
Verbose syntax.
Cobol syntax has often been criticized for its verbosity. However, proponents note that this was intentional in the language design because it made the code self-documenting, easing program maintenance. 53 Cobol was intended to be easier for programmers to learn and use, too. 1.1 But while being readable to non-technical staff such as managers ID/10-350, the desire for readability and good program documentation is why Cobol has English-like syntax and structural elements, such as nouns, verbs, clauses, sentences, sections, and divisions. Consequently, Cobol is considered by one source to be the most readable, understandable and self-documenting programming language in use today. Not only does this readability generally assist the maintenance process, but the older a program gets, the more valuable this readability becomes. On the other hand, by 1984, maintainers of Cobol programs were struggling to deal with incomprehensible code, ID/10, and the main changes in Cobol 85 were there to help ease maintenance. 48. Gene Summit, a short-range committee member, noted that little attempt was made to cater to the professional programmer. In fact, people whose main interest in programming tend to be very unhappy with Cobol, which he attributed to Cobol's verbose syntax. ID/14.
Alienation from the computer science community.
The Cobol community has always been isolated from the computer science community. No academic computer scientists participated in the design of Cobol. All of those on the committee from commerce or government. This was due to the differing interests of computer scientists at the time, who were more interested in fields like numerical analysis, physics and system programming instead of the commercial file processing problems Cobol development tackled. The Cobol specification did not use the new Bacchus-Naur form, resulting in severe criticism at the time. Cobol suffered from a shortage of material covering it. It took until 1963 for introductory books to appear. By 1985, there were twice as many books on Fortran and 4 times as many on BASIC than on Cobol in the Library of Congress 348 to 349. Later, as Cobol became a mainstream language, Cobol suffered as university professors taught more modern, state-of-the-art languages and techniques instead of Cobol, which was said to have a trade school nature. 351.
Flawed language features.
Cobol suffered from poor string handling facilities, which were only fixed in Cobol 74. The hard-to-spot and easily mislaid scope delimiting period was superseded in Cobol 85 by scope terminators, 25 years after the begin-end delimiters were introduced in ALGOL. Until Cobol 85, only paragraphs could be used in perform statements, which made programs harder to understand as the reader had to search for the body of the statement. 350 functions were introduced in the 1989 amendments and user-defined functions were only introduced in Cobol 2002.
Other defenses.
Cobol's data structures influenced subsequent programming languages. Its record and file structure influenced PLA and Pascal, and the redefines clause was a predecessor to Pascal's variant records. Explicit file structure definitions preceded the development of database management systems, and aggregated data was a significant advance over Fortran's arrays 349. The copy statement was a successful feature that became part of subsequent languages as an include directive 349. Until Cobol 2002, Cobol was a simple language with a limited scope of function, with no pointers, no user-defined types, and no user-defined functions, encouraging a straightforward coding style. This has made it well suited to its primary domain of business computing, where the program complexity lies in the business rules that need to be encoded rather than sophisticated algorithms or data structures. Standardization meant programs written in Cobol are portable, and language has since spread onto a wide variety of hardware platforms and operating systems. Additionally, the rigid hierarchical structure restricts the definition of external references to the environment division, which simplifies platform changes in particular.